Hello, everyone. We're going to go ahead and get started with today's webinar, Connectivity 101 for Remote Monitoring Systems.
Fantastic. Hey, Oliver, thanks again for getting us started, and special thanks to all of you for joining us today. I think you'll find this a really engaging topic, and based upon the attendance today, I can tell it is. Before we get started, I just wanted to kind of point out that this is kind of a broad range of topics we're going to cover or discussion items within this area. It's one of those interesting topics that spans a wide range of disciplines. If you're an automation controls engineer, some of this might be more in tune with HMI on your plant floor. If you're working on more geographically distributed applications, a little bit more related to SCADA. And, whether you're an IT person or you're an automation control engineer, I think there's something in this for you. We hope to share some tips and technologies and ideas to basically help you, in your day-to-day job to do more effective systems. Given that broad range of disciplines, I think I'd like to start off, and Oliver, I'm going to ask for a little help here. I'd like to start off with, just doing a quick poll with you folks, and would like to get your feedback on this that can help us a little bit today. And also, we use these to look at the future webinar topics. What's your number one challenge in implementing remote monitoring systems? And we've got a couple options here for you. And it's not a bad thing to have a technology skills gap. The fact that you're here with us today shows that you're looking to learn more and help your organization be more efficient and do some interesting things. So number one. Second one, that you're challenged with integrating existing and legacy equipment, right? It's not always easy to do a greenfield and rip and replace. Let us know if that's one of your concerns. Unreliable communications, or maybe you're doing a SCADA application where you can't get good coverage out there. Maybe it's the last one, and I don't think this is a bad thing, but it's often hard because of the differences amongst you, right? That collaboration between IT and OT, or OT being the operations aspect. Those of you folks that are the plant managers, the service people, the automations and control engineers. And lastly, network security. And probably a lot of you have multiple concerns. We'd just like to kind of get a quick poll on this.
Here you go.
All right, thanks, Oliver. Interesting. So I imagine that, depending upon the audience, we get a little different results. And as you can see, that I can see these resonate with a lot of you, and especially interesting. And I think the first part of this will be real appropriate for that big green one out there. How do you kind of take what you have today and get more out of it? How do you, integrate that existing legacy equipment? That's a perfect segue to the first part of this. So Oliver, if you want to put me back on the slides, let's go ahead and move on a little bit. And for today, just to give you a little glimpse of where we're going to go, I'd like to start from the edge of your network and work inwards. So I'll cover the first half, and then I'll pass it over to Ariana that can talk a little bit more about the infrastructure side of things in the network. So here's a couple of pain points, and I won't spend a lot of time on this. I think you folks already identified some of them, and they line up with this. And this is one of the challenges with doing remote monitoring, is it really takes a lot of different disciplines. And hopefully some of you today actually work hand in hand with your counterparts. I've seen some incredible things from organizations that find out how that IT and the plant floor can come together and understand their differences, and actually, use that to learn more about each other and come together on this one. So let's kind of start off with the first subtopic here. And again, these are kind of foundational. I know some of you might have some experience in certain areas. I guarantee there'll be something for everyone in today's webinar, and we'd love to build more on this series, and I'll look forward to your feedback after the webinar to see how we can, help deliver great, information to you folks on this one. And especially in the legacy place, it's not always easy to get everything to work on the same protocol. So let's start off here and talk about that. Let's start at the really kind of high-level aspect of this before we talk about anything specific. And I think historically, probably a lot of you have seen these types of protocols that utilize a pooled architecture, specifically for these larger geographic true SCADA applications. This also might relate to HMI, within a factory, within a shop floor. within the plant as well, where some portion of your system, and oftentimes they're a lot more complex than this, but you've got, basically your software tool that you're running, whatever that might be, requesting and getting responses from all the collected devices, be them PLCs, be them RTUs, be them other more complex systems. And, the challenge with these systems is they work really well and they've been out there for 30-some years. A couple examples of those that I think all of you immediately understand would be, Modbus on serial ports, for example, DNP3 to another extent for some of the utility type applications. And the challenges we have with those is that, the time it takes to make a complete round trip to get everything on the network and gather that and bring that up, relies upon, sending the request to the device. The device has to process that request and be able to formulate a response. That response has to be sent back to the SCADA host, the SCADA master, and then some turnaround time on that. That turnaround time means that you have to have the ability to kind of have a little bit of the time delay between responses. Some of you folks that know Modbus know that it takes 3.5 character times on a serial link for that. That would be an example of that turnaround time. So that's a little bit of our challenges with the pole type of architecture. So basically, here's some of the limitations. I spoke to a little bit of this, right? Sequential processing. The total time to refresh all of the items that you want depend upon how many devices, what the communication speeds are, how much data you're pulling on that one. And that might impact, how much data you can display on this one. Lastly, some of you folks that might be doing things that utilize, say, cellular connections through a cell modem or even satellite with various satellite technologies. The challenge with these is not only it's the fixed cost to install the communications hardware, but you've also got the operating cost of that. And generally, you'll find most of that, being based upon some type of usage, much like your mobile phone, right? That if you go over a certain amount of data on your phone, right, you're going to be charged excess fees for that. So lots of challenges with that, and I'm putting a lot together here across a lot of applications. But important things to consider if you're going to build out this type of architecture in your network. Another fundamental technology, and some of you folks may already be aware of this, particularly some of you folks that are involved in factory floor applications. Some of the foundation technologies that were introduced with the CAN-based networking and with like DeviceNet type technology from years back know about some of this, where the concept is you don't just poll even though there's no change in data, but rather send data as it changes. So if you've got a pressure sensor that triggers and goes on, you can send the change of state information. If you're sensing an analog value, like perhaps like a tank level, if that tank level doesn't change in 5 hours, you don't need to send that new value. You send it when it changes. You also may find that this type of technology, you might need to have a periodic refresh in case something comes on and goes off a network to send like a periodic update that as well. So this is all called report by exception. And is a really interesting way and really powerful way to be able to architect these larger networks, particularly when you're concerned about getting faster updates and also when you're concerned about being able to share information and minimize data usage. So in summary, some of the things look like this. So here's that same architecture. In this case, the field devices will push instead of being pulled from, and push that data up to the management system in which to do this. Some of this is a little bit, commonplace to some of the folks from the IT background. If you look at technology like Simple Network Management Protocol or SNMP, SNMP has the ability to send a trap, right? And that trap is an alarm message or an exception report. So utilizing this types of technology, minimize data transfer, get faster updates. Another thing that's kind of hidden for those of you folks that have to work in a segmented application, it's really friendly with routers and firewalls because it's initiated from the device and can propagate backwards if you're utilizing the network address translation or NAT type technology. The unfortunate part is not everything supports this. If you've got, for example, an RTU that's installed out in the field or a PLC that talks Modbus, there's just not an easy way to do that. A couple examples of the technologies out there. The more recent versions of OPC-UA have abilities to do a push type technology with report by exception. And some of you folks, particularly if you're doing work in water, wastewater applications and power, DNP3 protocol has some capabilities with which to do this. Another one, and I wish we had more time to go into some of these really interesting technologies, something that I've had a lot of interest in the last 5 years, and something that's starting to get a lot of interest across many areas. Some of you folks that have heard about this thing called the Internet of Things, or IoT. This has kind of been a real big buzz in that segment, but very useful for automation applications, building upon that report by exception. This is a protocol that was really built for doing applications for wide area networks like pipeline monitoring. And it's called MQTT, or Message Queuing Telemetry Transport. It basically builds upon an IT technology, and some of this foundations goes back to IBM, in which is very efficient utilizing this and utilizes that report by exception. So just want to drop a little buzzword here for you to tell you that, this is one of those pushes that's getting a lot of interest as of lately, and something that you might want to look at, and something that's really good topic for, the plant floor folks in IT to talk about how you might bring this into your architecture. And even if you don't have devices that support this, there are middleware and gateway type products that might be of interest in helping you bridge those two worlds. Next topic, let's kind of push ahead a little bit, and I think this one really resonates with you folks that answered the poll, right? What do I do about my legacy devices? How do I get them to come into this new network I'm trying to do? Or how do I kind of bring some new life into this and do more things with them? And I want to kind of talk about two parts to this. While technically not a protocol, there are some aspects for the hardware physical layer to those devices in addition to the protocol. So let's start off at that lower level, right? That lower level talking about, that passive aspect of it. A lot of you folks probably have assets out there that can be managed via serial port. Maybe it's a PID controller, maybe it's a PLC, maybe it's a digital scale, maybe it's a flow computer. I could go on and on with some examples of this. There's still needs. How can I take that fixed asset and get that on my network to remotely monitor management? Likewise, how can I bring on other devices that maybe have different types of protocols? Some of the approaches that some of you folks might know about might be employing already. Might be plugging in a specialized module into your PLC. Maybe it's installing a third-party type of box to do that, or a gateway. Or maybe some of you folks might have taken a more difficult approach, throw industrial PC at it, and if you're pretty proficient with developing software, write some C code to do that. This one's a little more difficult, and especially with all the different protocols we have to look at from some of the legacy serial-based ones as well as some of the newer ones, it can be a little challenge. So let's kind of look at that a little bit, and just categorically, I want to enlighten some of you folks that don't have this perspective, that even in that realm of being able to leverage existing assets with a serial port, don't forget about some of the foundation technologies out there. There's a category of product that allows you to take those serial assets and be able to overcome those distance limitations and the one-to-one relationships of your serial devices. And this whole technology builds upon something called a serial Ethernet converter. More common is to use the term device server or serial server. If you're an IT person, you probably know this as an old school type terminal server. And the concept of this is to use a small, inexpensive device. You can see kind of a form factor up in the upper right-hand corner of your screen that's able to connect these devices and be able to transparently move that across your network. And the way this works is kind of like that intermodal cargo container you see on your screen, right? So it doesn't care about what's inside the cardboard boxes. It basically works to put those cardboard boxes in the cargo container, and they magically appear somewhere else in the world or somewhere else across your plant floor. And you can use a couple of these devices together to move, serial data over Ethernet, or you can, have those go over, wider area connections between plants. And a great technology, and the great thing is that, these are plug and play. In about 15 minutes, you can have something up and running. And I know some of you folks might be thinking of, hey, one of these ends is a PC. There's also software available that a PC can be one edge of this or one end of this connection with device driver software to make it look like one of these device servers. Now, in some cases, you may find that you have to actually do a little translation, right? That last example with a device server means that both end devices, and you can actually have multi-point applications with that as well, have to speak the same language. So today, I'm coming to you via English language. If I were speaking another language, you'd have a hard time. And that's really the role of these devices called an industrial Ethernet gateway. And the really cool thing about this is, a lot of work has gone into designing these, that these can basically be used to translate amongst protocols. So an example here showing maybe a SCADA system that's capable for doing a Modbus TCP across the network. But there's an asset out there, and there's a lot of reasons for this, especially for a lot of applications for the legacy perspective, or doing best-of-breed applications that might use other protocols, that you can bridge those connections. And this utilizes this concept of a drop-in solution called an industrial Ethernet gateway. And let me go a little more into the concept for you folks that aren't familiar with this to kind of get a little better glimpse of that. So it looks a little bit like this, and just take you through this really quickly. On the right, we've got a PLC. This example uses Ethernet IP. On the left, we've got that Modbus system that's maybe an HMI application or SCADA that wants to do that. And what's happening is we've got a little small polling action happening over here on the right, where this gateway is able to poll and look for certain devices, and this can be read and write access to it and maintain an internal data table. So those of you folks that are familiar with PLCs would see this is really similar to your scan cycle. And then on the left-hand side, now that data is available inside of the gateway, now at any time you can send a request to the gateway in your native protocol, in this case Modbus, and retrieve that. So really great solution. You don't have to change the program to the PLC. You just need to know what objects you're looking for, and you can quickly drop this in and be able to bridge different devices with this type of technology. So good one to think about there, and a great drop-in solution, kind of building out your arsenal of tools to be able to do these remote monitoring applications. Let me push on a little bit and cover a couple other topics, and again, we've got a pretty quick pace to this. Again, we'll have some room for questions at the end. So in planning for these, expect communications disruptions. These can be intentional or unintentional. And a couple things to think about in architecting these, and this is the time to think about this, is, plan for those. You want to think about backup connections. Some of those backup connections may come within your infrastructure. They may be backup links, backup, the secondary serial connection, a secondary Ethernet connection. Some of this comes within your infrastructure on this if it's wired, right? If it's a wireless application, don't forget that the same concepts apply to that. And in fact, you might even have hybrids of both of these. The primary connection is wired, and maybe you want a backup wireless connection. That maybe it's too costly to do all the time, but maybe you need to have that resiliency and redundancy. So a lot to think about. I think we've kind of done some wireless topics in the past that talk about some of this. So certainly we'd like to we can point you into more details for that, to look at that. But things to think about are, your signal coverage, your antenna placement, your data fees, and some of those things, and kind of finding the optimum solution for that as well. And lastly, when you're choosing, the types of devices to deploy, don't forget that cellular types technology is wireless, and it's not, is reliable as a wired connection. So it's gotten much better in recent years, but you got to kind of plan for these types of exceptions. So make sure in your solution that you look at ways that the devices are able to not just connect once, but if there's a minor disruption, to be able to intelligently reconnect, right? You don't want to have one of your team have to jump in the truck and go out to the site for a 4-hour drive and have to go, jiggle something to get it to come back online. And this means these devices are designed for this application so that if the cellular connections drop, that it's able to reliably reconnect, that it's able to reset the cellular subsystem if that's a problem. And in some cases, and these are complex systems, it might even require just a device restart to this. These you'll find in the better designed products that are able to handle this type of automatic reconnect if need be, whether this is a cellular router or a cell modem or even an edge device that might be you're tying remote I/O into your system. And lastly, some of that might mean thinking a little bit about your strategy. One of the great things is that our technology for wireless has kind of been pushing towards a global deployment with the LTE standard. And, it's great that you can get greater bandwidth, but it's more important that you can have a common carrier or a common technology across carriers. So one of those strategies might mean, utilizing devices that can work on multiple carriers. So while you might prefer to use, say, for Verizon for your primary carrier, having an ability that you could possibly fall back to a secondary carrier if that cell tower went offline for some period of time. So good things to kind of think about in planning for your remote monitoring systems for that. Next, a couple other small topics here. Again, just kind of a couple things to think about. What happens if you do lose that connection? In some applications, the data is, really important, and sometimes that data needs to be collected somehow. One means of collecting might mean to buffer it. I can point to several applications and some shop floor applications where the data is streaming, and there needs to be something catching that. That could be like scale application, barcode scanners. In some industrial applications, I know one, for example, is streaming live data off of well site monitoring applications, and that just needs to kind of come. And if you've got bad weather that comes in like a thunderstorm and reduces your satellite coverage, you're going to lose that data. So this is possible, the right infrastructure to buffer that, maybe even in the edge device that does that. Also think about offline storage. If there's some attenuating circumstances for this, you might consider having infrastructure that's able to do some data storage, data logging, right? Some of you might want to write programs to do this within some of the I/O equipment that goes in the cabinet. So think about that. Think about, do you have to have a date timestamp on that? How can you capture that if there's a momentary disruption, and then be able to start pulling that back into your process after the effect? So great to think about that. And then lastly, and this is more of that contingency planning, don't forget the situations where you may lose that connection, and now what happens? Is there enough intelligence in devices that you have installed to be able to maintain some level of control if need be for doing that? So if you think about perhaps maybe a remote pumping station, especially this time of year as we're kind of coming into winter and we get, more rain, if I lose SCADA connections, do I need to have an alarm that happens that starts that pump if a level rises, even if my SCADA system is down? So if you don't have that intelligence, maybe you might want to consider some simple local control to be able to do this and have that part of your system. Even if you're not a PLC programmer and that's not part of what you do, selecting end devices that do some of this. With that, I want to invite Ariana to kind of pick up the second half here, and I'm going to let her talk with you about some of the other things to think about. Now, Ariana, I think you're going to start talking about security. So let me hand it over to you. Thanks, Ariana.
That's right. Thanks, Paul. And hello, everyone. I'd like to extend my warm welcome to all of you. Certainly appreciate having you here today. And thanks to Paul for an awesome first half of the webinar. I'm going to shift topics a little bit. I shouldn't say shift topics, but shift the focus of our topic a little bit to more of the networking and infrastructure side. And the first thing I'm going to talk to you guys about for a little bit is security. And why it's really important to think about security from the start of when you're designing your network rather than having it just be more of an afterthought, which is what we're kind of seeing some people doing in these days. So So I want to start with a quote by a gentleman named Bruce Schneider, and he's a very well-known security technology expert. And he had a quote that I thought was very, very fitting when it comes to cybersecurity. And he said, "The reality is that security is not something you can buy; it is something that you must get." And what that means is that you can't just snap your fingers or wave money at a solution and have it be secure. It's something that you really need to think about and develop from the onset if you want a truly cyber secure system. So why is this important? We've had in recent years a number of cybersecurity incidents. Some of these you guys have probably heard of, some of them perhaps not. It all started back in 2003 in Ohio. There was actually a nuclear power plant that was hit by a SQL worm called the Slammer. And it basically caused the plant safety monitoring system to shut down for 5 hours. And I don't know about you, but it kind of scares me to know that there's a nuclear plant that potentially is disabled, that nobody knows if it's leaking anything toxic, and that was kind of really the first wake-up call that we had for our industrial space. Prior to that, most of the cybersecurity incidents that happened were more on the consumer or the commercial side. Things were quiet for a little while. The next major one was actually in 2010. You guys probably heard about this one, but this was basically the Stuxnet virus that took control of Iran's nuclear program, and very similarly, it had disabled a lot of systems within a nuclear facility. In 2012, there was a major oil and gas producer that got hit by a virus called the Shamoon virus, and it basically was malware that got hit or that went into their systems. And even to this day, we actually are still seeing some of that malware proliferate into those systems. So these things are very difficult to get rid of for good once they actually, permeate your systems. And the most recent one was in 2014, so not too long ago, but it was basically what's called the Heartbleed virus. And this was something that took out systems worldwide. Similarly to the malware that we saw in 2012, this is something that continues to affect systems globally today. The key message from this is really no vendor, no user, no market. No one is really immune from a potential cybersecurity incident. And that's why, we really say, hey, think about cybersecurity in the beginning when you're designing your network instead of afterwards when it might be, almost too late. The other thing that we're starting to see as a trend here in the industrial space is, critical manufacturing incidents. So in 2013, there were basically 257 known attacks or known vulnerabilities that happened within our space. And you can see here that about 56% of that was in the energy sector. In 2014, there were slightly fewer, 245, but what you can see here is a trend. The energy decreased down to 32%, and critical manufacturing, where I think a lot of us live, bumped up to 27%. And then in 2015, there were an increase in the number of incidents to 295. But what's most startling is critical manufacturing is now the largest portion of those incidents. So a little bit scary and definitely something that we want to keep in mind. So what happens if we want to, include cybersecurity in our plant network? Well, I would like to give you guys a few of the best practices and ways to kind of decrease that cybersecurity risk. We really recommend kind of a multi-tiered approach, meaning you don't have just one thing that's going to stop a cybersecurity attack. You have multiple layers of things that really are geared to stop, increasing attacks as people are trying to get to these, devices, within your facilities. So the first one is, really plant security. And this is something that most people do. Most people have key cards, passwords, fingerprint scanners, some sort of physical security to basically prevent people who are not authorized to be in that facility from being there. Then you want to have network security, and this is one that sometimes is taken over by the IT department. It really depends on, the company. Some IT departments like to handle all of the network security. Some will only handle the, the office side and let the OT handle the industrial side. But either way, this is something that definitely needs to be taken into account. And network security is something that basically will control the interfaces between the office and the plant network. What that means is using a firewall. And so So that really helps to make sure that what's going on the plant side is not affecting what's happening on the office side and vice versa. Finally, making sure that you have the proper system integrity. So this includes things like, making sure you have user authentication either via Radius or TACACS or something similar for plant or machine operators. Making sure that you have antivirus installed on the PCs that are on the plant floor, having a whitelisting policy, making sure that all of your devices, whether it be PCs, serial devices, Ethernet switches, really making sure that those are all updated and patched for any known cybersecurity vulnerabilities. And then finally, access protection mechanisms for automation components. So make sure that people who are not supposed to be given access to these automation components aren't able to get to them and do something maliciously. So with that, I'd like to take a quick poll here. Paul started off with one. We've got this one and one more for you guys, but I'm kind of curious to know, have you been impacted by cybersecurity issues? And, our potential answers are, I've had systems hit or been vulnerable. I know of others that have been hit, but my company has not. Or the third one, which hopefully, you guys will say, because that's not fun, is I've never had any issues with cybersecurity. So we're getting a few answers coming in here. We're going to give you guys just a few more seconds to vote.
Don't worry, guys. We're not going to tell your boss if you end up choosing that you've been hit by cybersecurity. But
Sorry, guys. Oliver cut off a little bit here, but we're going to go ahead and show you guys the results of the poll. And it looks like about a quarter of you have never or have had systems hit or been vulnerable, which, I'm sorry to those of you. I know that's definitely not an easy thing to deal with. Another little over a quarter of you also said you know of others that have been affected, but fortunately I have not. And about half of you have not had any impacts of cybersecurity. So I'm definitely glad that you guys haven't had any issues, but again, it never helps to, it never hurts to be prepared, and that's something that, unfortunately there's a possibility that you may experience in the future. All right, so appreciate the time here for our poll. We're going to go ahead and keep going on here. So again, kind of sticking with our defense in-depth strategy, a few of the ways that you can do this. So we really recommend that you employ lifecycle processes. So taking a threat assessment, meaning how secure are your devices, how secure is your network. Implementing countermeasures to those threats. So, if you have a device that maybe is not secure, how do you patch it? How do you get it updated? How do you get it secure? And then finally, once you've really done both of those things, making sure that you monitor and maintain that security level so that nobody can actually get into your system once you've done that initial cybersecurity assessment. From a network segmentation breakdown, there are a few things that you can do to help kind of keep things a little bit more secure, and that is really to kind of segregate your network according to roles or according to zones. So this basically has four possibilities. One, you can break down into the physical or logical zones, meaning you can do something like a plant floor if it's a small facility and an office floor, right, being two different zones, or maybe if you have several manufacturing lines, each manufacturing line being its own logical zone. You can group them by security requirements. So maybe there are some computers on the plant floor that need access to some data that's stored on the office floor. You can group those into logical ones by using VLANs, for example. Really make sure that those borders are clearly defined. So don't accidentally let somebody who is unauthorized to be in a zone be in it. It's always helpful to really double check those types of things. And then finally, define zone-to-zone interactions. So perhaps you have manufacturing lines that on occasion need to talk to each other. You can use firewalls to allow things like, policy exceptions to allow those devices to communicate with each other. But we really, make sure that only traffic that is supposed to talk to each other is talking to each other. And if you follow those different types of things, that's a really great way to make sure that your network from the office floor down to your plant floor is secured and really done in a manner that will leave you not vulnerable to cybersecurity incidents. So for example, here we have a secure pipeline monitoring application. In this example, we have basically a control center that is looking to talk to all of these different gas transfer stations which are remote from the control center. Now, if we talk about logical zones, each of these gas transfer stations would basically be its own zone. And when we talk about the intertransfer of data between different zones, you basically would have perhaps one transfer station needing to talk to another, or perhaps the control center needs to pull or get data from those stations. You can basically use routers and firewalls to help keep those zones separate while still allowing the appropriate communications to take place. For those of you who are not familiar with firewalls, to break it down into basic terms, you basically have an external or unsecure zone and an internal or secure zone. And basically anything coming in from the external zone has to be either accepted or dropped by the firewall. And the way that it determines that is based off of the policies that you basically put into the firewall. And it's really important to make sure that you are only accepting the appropriate traffic coming in through the firewall, because that's really your best point of guarding against any kind of cybersecurity attacks. Firewall policies can be set up, based off of IP address, based off of MAC address, based off of protocol, based off of, IPs and port numbers. There's all sorts of ways that you can basically allow or drop connections. And just as you can, allow all these things, you can also deny all these things. So, for example, say you want only Modbus protocol to come into your network, but not Ethernet IP, for example. You can actually set up the firewall policy to block all Ethernet IP traffic while allowing Modbus traffic. So firewalls are really great because they can get very specific in terms of what data you will allow or deny to come into your network. So this is what kind of an industrial firewall would look like in terms of policy processing. All of the firewall policies that you put in place are basically stored in lists or easy-to-see tables. And the firewall will go through them sequentially. So, typically what is good practice is to list all the accepts first. So basically say, I want to accept Modbus traffic, and I want to accept all traffic coming from this IP address. And then after that, you can end with drop. So it'll accept those two things and drop any other traffic that's trying to come into your network. Typically, there's going to be basically two types of firewall rule tables. So if the default condition is to drop all the traffic, and we list all the accept conditions in the previous index, then we call it, let's basically call it a positive listing. And if the default condition is to accept all traffic, and then we basically list all the drop conditions, then we call it a negative listing. But it's always best practice to use a positive listing because this will allow less traffic in than a negative listing. Another good way to secure your network is by using VPNs. What we're seeing more and more nowadays is remote sites that are all being pulled or all sending information from a central headquarters or a central control room. And one of the great ways to do this securely is by using what's called a VPN, or virtual private network. A VPN essentially can connect together remote sites that function as if they're on the same secure logical network. So what this means is you can bring together all sorts of locations, all sorts of users, all sorts of sites, but still not have to worry about security of somebody seeing the data that's being sent from those sites into a central control room. Some of the key features of a VPN, there are some standards. IPsec and OpenVPN are the two most popular ones, and they basically just create a secure tunnel over an untrusted network. So you can take a line like the internet, for example, and you can basically make that secure by use of a VPN. The great thing about VPNs is they only allow authorized users onto the network. So there are two ways that you can basically authenticate users. This is very similar to the way wireless authentication works. So if any of you are familiar with wireless networking, you can use a password, which is also known as a pre-shared key. That's basically where you type in a password. If it matches what's set on the VPN, it will let you onto the network. Or it can use a digital certificate by using something like a radius server to actually authenticate that certificate. That's also referred to as enterprise level authentication. And that certainly is the more stringent one, but takes a little bit more effort to implement. So the majority of people will implement the password-based authentication. VPNs will also ensure your data integrity. So not only do they create a secure connection for you, they also make sure that the data that's sent is the data that's received on the other end, and that hasn't been altered by somebody tapping into the line in between them. So there are checks and balances in place within these two VPN tunnels that will make sure that your data has not been corrupted or altered in any way. And then finally, I kind of mentioned it already, but it basically encrypts the data. So even if somebody theoretically were able to tap into a VPN connection, which is not easy to do, the data that they see would not be plain text data that you basically send out. It would be encrypted data. So there's a couple of common use cases. The first one is what we call remote access. So in this circumstance, you can have a many-to-one type of a connection. So you may have many remote sites that are all connecting into a central room. It can also be a many-to-many depending on the type of VPN or the type of remote access that you're looking at. The other one, which is kind of a little bit more of the traditional one, is the site-to-site. So this is basically a dedicated tunnel that exists between one location and another location. So another best practice is to really select infrastructure that supports remote monitoring. And I'm going to spend just a few minutes here talking about that. So what is it that you do? What happens if your SCADA or your HMI shows a device that's offline? What if your PLC shows an Ethernet remote I/O that's faulting or not functioning properly? What happens if you're having SCADA communication faults, right? All these things can really hamper efforts to get data to where it needs to be. So one of the easiest ways, or I shouldn't say easiest ways, but one of the most common ways is to use what's called SNMP. Paul kind of talked about it very, very briefly earlier. It stands for Simple Network Monitoring Protocol. It's also known as what's called the Modbus of the IT world. So SNMP is basically a way to manage devices on the network, and these can be things like PLCs, they can be HMIs, they can be Ethernet switches, and typically there is a software that basically will be able to do all this management for you. But it basically is a set of framework that really provides facilities for managing and networking, managing and monitoring all these network devices. So there's three parts of it. There's an SNMP agent. There is a manager or a network management system, which is also referred to as an NMS. That's the software portion of it. And then there's the management information bases, or MIBs, which basically tell the NMS what can be managed on the agents themselves. And all these things basically work together to make sure that you're able to monitor and manage all these devices remotely. So we're going to do one more quick poll for you guys here, and our question is, how does your organization interface IT and the plant floor? So we've got a few different options for you guys. The plant floor controls all networking. IT stays out of it, which for some of you guys is probably going to be the easier solution. IT controls both office and plant networks. IT oversees the plant network, but we design and maintain it. And finally, we work together to create the plant network. So we'll give you guys a few moments to vote on that one here.
All right, this is going to be one of the more interesting poll results, and we'll be sharing the results momentarily, but let's give you guys a few more seconds to get your votes in. And you want to take bets on which one is the most prevalent answer among yourselves. We're going to find out in just a second.
Actually, there's one that's dominating, surprisingly. So
Surprisingly. Let's go ahead and take a look and see if you're as surprised as we are.
All right, so it looks like about 19% of you says the plant floor controls all networking and IT stays out of it. They mind their own business. But 21% of you say that IT controls both the office and the plant networks. That one was the one that I actually thought was going to be the most popular. So kind of interesting to me that there was another one that was the most. The third option, which was the least popular, IT oversees the plant network. We design and maintain it. And by far, the majority of you said that we work together to create the plant network. And that one actually is really the best way because it's really important that IT understands the critical nature of the manufacturing aspect of the networking. But it's also important that the manufacturing aspects really adhere to the policies that IT has put into place. So I'm glad to see that a lot of you guys are working together. And thanks, guys, for voting in that poll. Going back to SNMP for just a moment here, these are some of the things that you can see or do with devices that support SNMP. So you can see things like system status, if a power supply is operational, if there are any faults that are going on the system. If you're talking about an Ethernet switch, for example, you can tell if a port is up or down. You can see what speed that port is set to. If you're talking about traffic monitoring, you can see how many packets were sent, how many were received, if there were any errors. There's a lot more. And you can actually see this table is a little bit small, so I apologize, but basically, this is a table, an example of some of the things that you can actually do with SNMP. So you can see that you have a get set. So get means you can basically read or pull a device for that information, and set means you can basically set that information using SNMP to that device. So it's a very powerful thing. It's something that if you guys haven't already looked at, I would definitely highly encourage you to take a look at. It can make your lives a lot easier. So it also helps you to really monitor your infrastructure. There are, a lot of people who have dedicated SNMP servers, and those are a great best practice to have because they can actually interface between the networking side and the industrial automation side. One of the nice things about SNMP is it tends to be somewhat vendor agnostic. So you can have various vendors that have different types of products that'll all work together with an SNMP server. The other thing is that, oftentimes you can manage through industrial protocols as well. And this is something that requires you to know a little bit more about the protocol that you're potentially using. But in this case, you would have an HMI or a SCADA or a PLC, for example, that supports some of these common industrial protocols like Modbus, Ethernet IP, Profinet. And the nice thing about Ethernet switches, in particular those that are managed, is that they typically will tend to support a lot of these protocols. Some switches will even allow you to, or even support tags for, Modbus, for example, or Profinet or Ethernet IP. And that means that you can actually monitor the networking side of it through an HMI or a PLC or something to that extent. Network management and maintenance is something that if you had asked 5 years ago, very few people were actually doing. But really in the last 5 years, it's kind of exploded because of what you can do with it. So for those of you who aren't familiar with NMSs or network management software, I briefly mentioned it a couple of slides back. But basically, this is a really great way to monitor and manage devices on your network. Most NMSs will include support for SNMP. That's typically how they manage and pull devices that are being viewed in them, but it's really a great way to visually see what's happening on your network. So you can see the screenshot that I have up here, for example, will show you the different switches. It'll show you what devices are connected with the switches. It can let you know when there's a problem with the switch, and it actually does a lot more than that as well. You can do real-time event management and performance reporting. So to those of you that have networks that are quite large, they can be very difficult to manage, and sometimes if there's a problem on a part of the network, it can be very, very difficult to isolate where that is. Network management softwares will typically include some features that you can use for diagnostics. So for example, they can let you know when a switch is down. You can monitor the bandwidth that's going across a link, and if it gets too high, you know that maybe you have a broadcast storm issue, for example. And network management software is just a really easy way to get a very good overall glimpse of what's happening within your network, and will let you manage those devices as well. A few other things that you can do with network management software, in particular with Ethernet switches, there's a whole lot you can do. You can actually have virtual device panels, so you can actually pull up a device panel and all the lights, all the ports will light up as if you were physically looking at the switch itself. This is particularly handy for when you're looking at or trying to troubleshoot a switch that's at a remote location or somewhere that you basically don't have access to. You can also have real-time events, so whether that be setting an SNMP trap, that's something that Paul had mentioned earlier in his portion of the presentation, whether it be setting an email, those types of things can be known to you in real time when there's a problem on the network. It can even go one step further. A lot of network monitoring softwares actually will include a mobile version. So say, you're a network engineer and, you happen to be out at lunch and your network goes down. You can actually get push notifications sent to your phone letting you know that there's a problem with your network. That way you can kind of easily diagnose it and potentially take action from wherever you are, even if you're not actually on site to be able to address the issue. And with that, I believe that concludes our presentation portion of it. So thank you all so much for attending. I hope this has been educational for you. At this point, we're going to go ahead and open it up to Q&A. So if you have any questions for either Paul or myself, we'd certainly love to answer them for you guys. And please feel free to type them into your questions pane.
We've already taken a couple of questions, but in case you need a refresher, if you had any questions about any portion of the presentation, whether it involved working with protocols, integrating legacy devices, minimizing communication disruptions, working with cellular connections, maybe you have a question about MQTT, routers, SNMP, network management, definitely now's the time to submit them. Let's go ahead and start out with a question from Chris. What is the latency with device servers?
Hey, Oliver, thanks. I think I can take that one. So, with any type of gateway device where you have to bridge communications, there is a little bit of delay in processing. If you're talking about latency, Chris, I suspect you're talking about, what's the impact on a message I need to get from one device to another. Bear in mind that one of those links is going to be a serial port, so you do have to factor in the communication bit rate on the device. But in general, plan for about 5 to 10 milliseconds of delay, with that type of technology with the device server for serial Ethernet communications.
Thank you very much, Paul, and thanks for the question, Chris. We have a question from Vincent. Is MXView agnostic?
Yeah, thanks, Vincent. Great question. I believe you mean is it vendor agnostic? Yeah, actually, MXView is, as well as most NMSs, will be vendor agnostic. So what that means is as long as there's a device that supports LGP and SNMP, typically you can view it and do some basic configuration of it. Obviously, each vendor will have their own specific functionality that they build into their products, but on the whole, including MXView, yes, NMSs do tend to be vendor agnostic.
Thank you, Ariane, and thank you for the question, Vincent. We have a question from Eva. Which protocols are supported by device servers?
Oliver, I think I can take that one. So again, with that bridging legacy devices out there, the device servers as a category are really good with a lot of different protocols. I think the most important thing to look at there is, number one, confirming that at both ends of that connection that they're utilizing the same protocol. So if you're trying to move Modbus RTU, works good for that, DNP3, DF1, all those work really well. I think the only exceptions you'll find, and again, I would encourage that if you're looking at this technology to get one for your lab and do a little bit of proof of concept just to confirm. But the outliers are things like Profibus that does run on RS-485 but has some extremely tight timing requirements. So again, very transparent. Almost all serial protocols will work as long as you have the same protocol on both ends of the connection, except where there's some timing issues.
Thank you, Paul, and thank you for the question, Eva. We have a question that sounds like it might be related from Bob. When you have a daisy chain of RS-485 Modbus RTU legacy devices, all with their own node address, example 1, 2, 3, 4, etc., how can this be converted to Ethernet?
Oliver, I think that's probably another one for me here from the edge connections. So I think the mention there is the RTU slave ID. And generally, my experience has been most of the slave devices, or most of the softwares out there, in the design of going to Modbus TCP, have a way to specify that. And that's kind of assuming you're doing Modbus TCP to Modbus RTU. That's part of the design of the Modbus TCP protocol. If you're doing cross protocol, let's say, for example, I need to do Ethernet IP to Modbus RTU. Yes, there is a way to specify that specific slave address as well as to specify the registers that I want to get access to. Hopefully that made sense. If not, I think, Oliver, after the event today, I think we're going to provide some additional contact information if you'd like to follow up with, one of our application engineers or field personnel for more detailed conversations.
Yes, correct. That's right, Paul. We will be sending a follow-up to everyone on the call with written answers to questions we weren't able to get to. And just so you know, you're also free to engage with any Moxa rep at usa@moxa.com if you have more detailed questions or you want guidance with your specific project. Here's a question from Adrian. Does Moxa see more people using OpenVPN or IPsec? I don't know if I pronounced that right.
Yeah, I believe that's a question for me, Oliver. And yes, you did pronounce that right. Thanks, Adrian. Yeah, that's a great question. We actually see, I would say roughly 70% of the people that typically will use IPsec versus OpenVPN. OpenVPN is actually an open standard, hence the name OpenVPN, and tends to be supported in more devices than IPsec just because of the open nature of it. However, the bandwidth with OpenVPN tends to be a little bit more variable, meaning you can't really consider a steady bandwidth when talking about a VPN tunnel. IPsec tends to be a little bit more stable. It tends to have a little bit of a higher bandwidth. So to those people who are worried about those types of things, that typically tends to be the solutions.
All right, thank you very much, Ariana, and thanks for the question, Adrian. I'm afraid that's all the time we have for questions, but there were some great questions, and don't worry, even if we didn't get to your question today, we will be sending up a follow-up email within the next week or so with answers to the questions on the call, even the ones that we missed, along with slides for download and a recording of today's session. Paul and Ariana, any final words?
Yeah, I think we're good, Oliver. We certainly appreciate everybody's time and energy today. We know you guys all have very busy schedules, and we appreciate you taking the time to spend a little bit of your day with us.
And thanks, Ariana. And then I'd just like to extend the same to you folks. And also, our ability to do this really depends upon getting feedback from folks like you. So I'd encourage you to let us know on the evaluation that comes out what other topics you'd like to see from us. I know it's really challenging to learn new technologies, especially with how busy all of you are today, but we'd love to hear feedback from you on other things you'd like to see and how we can help you, solve some of your day-to-day and problems and maybe things that might keep you up at night. Thanks again.
Thank you for tuning in, and we hope you enjoyed our presentation.